Hello viewers, welcome to RKD classes. Today's video lecture is all about your thermodynamics, and this video lecture we are going to discuss the unit conversion part related to your IIT exams, CSIR NET and IIT GATE, right? So what is thermodynamics? The study of transformation of one form of energy to another form of energy. For an example, suppose you intake your food, that means you are consuming chemical energy there. Because of that chemical energy, and you are walking, and suppose you are running, that means what happens, your chemical energy converted into your mechanical energy, right? Now the question is, what is the mode of this transformation of this energy, right, from one form to another form? That mode of transformation via your heat and work, and this heat and work depends upon the type of system you are considering. And what is that system? System is the part of universe where you observe the transformation of your heat. There is basically three types of your system, that is your closed system, open system, isolated system. In isolated, neither energy transfer nor matter transfer, but in open system your both energy and matter transforms. But in case of closed system, only energy transforms but matter does not. Okay, so coming to the next slide. In closed system, energy transforms, that means the mode of transformation through via your heat and work, and heat can represent in thermodynamics term, that is TdS, that is T and S is your variable. Okay, T and S is a variable here in case of a closed system. And for work you can represent like this, minus P dV, and here P and V your variables, that is entropy, pressure, volume and temperature, your variables in your closed system. And corresponding these variables you have Gibbs free energy, enthalpy, Helmholtz free energy, and your internal energy, your corresponding energy function, and your thermodynamics potential. Both same in case of closed system and open system, because open system related to your energy transform, that is same Q and W. But here in open system, the extra thing is here matter transfer, that means matter related to your amount. The amount, in terms of amount, you will say this is number of moles, this number of moles, and this number of moles, it's corresponding to its thermodynamic potential or energy function is your chemical potential. Coming to the next slide. That means we covered our observation towards S, P, T, V, N, G, H, A, U, mu I, W, Q. All these represents energy, right? All these represent energy. See here, all these represent your energy function or thermodynamic potential, all represent your energy. And coming to the point, S with entropy. Entropy can represent like this, dq by t, that means it is energy, it is also related to energy. What is that? Kelvin. Kelvin has to know nothing to do with that. That means your temperature and your moles, that is Kelvin, mole, it's have nothing to do with your means your energy conversions. For like unit conversion, you don't need this one, this temperature and number of moles. But you need to have your unit conversion, like your pressure, volume and energy. You need to have your unit conversion there. Okay, so next, coming to the point, how this unit conversion taking place, right? So for the unit conversion, suppose you have a cube here, imagine a cube, that means 1 meter length and 1 meter breadth, and this is suppose 1 meter height there, that means in 1 meter length, breadth and height contains 1000 liter. This much of volume contains 1000 liter. You have to imagine like this, that means 1 meter into 1 meter into 1 meter, height, breadth and length, right? It is having here 1000 liter. That means 1 meter cube is equal to 1000 liter there. That means 1 meter is equal to 10 decimeter. That means 10 decimeter. That means 1000 liter. That is 10 to the power 3 decimeter cube is equal to 1000 liter. And you know that very well. 1 meter is equal to 100 centimeter, or 1 decimeter is equal to 10 centimeter, or 10 decimeter is equal to 100 centimeter. As you can transform this one, that means 100 centimeter and 100 centimeter is equal to your 1000 liter. That means 10 to the 6 centimeter cube is equal to 1000 liter here, right? So you can convert like this, that means 1 meter cube is equal to 10 to the 3 liter 10 to the 3 liter, right? You can convert like this. That means you have to put this value in terms of 1 liter. That means 1 liter is equal to 10 to the power minus 3 meter cube. It comes here, right? Similarly, 10 to the power 3 dmq is equal to 10 to the power 3 liter, right? That means 1 dmq is equal to 1 liter here. Similarly, 10 to the 6 centimeter cube is equal to 10 to the 3 liter. That means 1 liter is equal to here 10 to the 3 centimeter cube. And you should remember that this is 1000 liter is equal to 1000 into 1000 milliliter, because 1 liter is equal to 1000 milliliter. That's why you are multiplying it 1000. That means 10 to the 6 centimeter cube is equal to 10 to the 6 milliliter, and you cancel here it, and you find 1 milliliter is equal to 1 centimeter cube. So from this observation you can do a shortcut like this. So coming to the point, that means 1 meter cube is equal to 10 to the 3 liter. 10 to the power 3 liter. 1 meter cube means what happens? 1 meter whole cube is equal to 10 to the power 3 liter. That means you can convert like this. 10 decimeter whole cube is equal to 10 to the power 3 liter. That means 100 centimeter whole cube is equal to also 10 to the power 3 liter. So you come here and you find here 10 to the power 3 dmq is equal to 10 to the 3 liter, 10 to the 6 centimeter cube is equal to 10 to the 3 liter, and simultaneously you can convert like this. 1 liter is equal to 10 to the minus 3 meter cube, 1 liter is equal to 1 dmq, 1 liter is equal to 10 to the 3 centimeter cube. You have to remember this one, you have to remember this factor, right? 1 liter is equal to 10 to the minus 3 meter cube, 1 liter is equal to 1 dmq, 10 to the 3 centimeter cube, right? Practice it, you will easily remember this one. Now the pressure unit conversion will like this. 1 atm is equal to 101325 newton per meter square, 101325 pascal, because newton per meter square unit is same as that was pascal, that is 101.325 kilopascal and 1.01325 bar. Right, pressure is equal to force upon area. Pressure is equal to force upon area. Force unit is equal to Newton, and if you convert area in meter, that means your meter square, and Newton by meter square is your Pascal. Coming to the point, next slide. 1 atm is equal to 101.325 Newton by meter square. Right, the pressure is equal to HdG. Right, height, density, and gravity, and you apply this one, and this is your class 9 10th factor, and you can check from a book. We don't need that, we just need this factor, that is 101.325 Newton per meter square, that is 101.325 Pascal, because Newton per meter square, your unit is same, that is Pascal. That means you can convert like this, 10 to the 3 Pascal, that means 101 into 10 to the 3 Pascal. 10 to the 3, you know that 10 to the 3, that means kilo, because 1 kilo, when you turned 1 kilo, that means 10 to the 3, kg 10 to the 3, right? Kilo 10 to the 3, that means 101.325 kilo Pascal, 101.325 kilo Pascal, right? So next, coming to the point, that means you can convert like this. 1.0135 into 10 to the power 5 Pascal, that means 101.325 10 to the power 5, 101.325 bar, because 1 bar is equal to 10 to the 5 Pascal, that is 0.101.325 is your 10 to the 6 Pascal, that is 101.325 mega Pascal. And you know that mega, that means your mega, that means 10 to the 6, mega, that means 10 to the 6, 1 kilo, that means 10 to the 3, right? So in this slide you can remember this one. 1 bar is equal to 10 to the 5 Pascal, right? And you can remember like this, Newton per meter square Pascal, and 1 bar is equal to 10 to the 5 Pascal there. Okay, right? So that conversion end up like this, 101.325 Newton per meter square, 101.325. Just remember this value 101.325. You can easily remember the units also. Pascal 101.325 kilopascal and 1.01325 bar. That's why whenever we consume, that is our value, that is we already mentioned that 1 atm is equal to your 1.01 bar, or right, that is rounding up to 1.01, right? Okay, coming to the next slide. Now important relation, you have to remember that 1 liter bar is equal to 100 joule. How? Because 1 liter into 1 bar, 1 liter bar, that means 1 liter into 1 bar, and 1 liter into bar, you have to remember that when you are converting to joule, that means you are converting 1 bar 1 liter. Someone asking you 1 bar 1 liter, convert into joule. Remember this one, Newton into meter always. joule, right? So that means you will convert this liter into meter, right? And you convert bar into Newton, right? As you have the conversion, you know that 1 bar is equal to 10 to the 5 Pascal. That means here 10 to the 5 Newton per meter square, because ultimately you will convert this into Newton, and ultimately you have to convert this into meter, right? That means 1 liter is equal to 10 to the minus 3 meter cube. Multiply it, 10 to the minus 3, 10 to the 5, that is 100. Here you cancel it, here you cancel, you find meter there, that means Newton into meter, that means 100 joule. Confirmed? Now coming to the next point, that means you can convert like this: 1 joule is equal to 10 to the power minus 2 liter bar, right? So you can convert like this: 1 joule is equal to 1 kilopascal liter, 1 joule is equal to 1 kilopascal liter. How will do it? 1 kilopascal is equal to 10 to the 3 pascal, 1 liter is equal to 10 to the minus 3 meter cube, right? So you convert this like this, cancel, that means 1 pascal into meter cube, 1 pascal meter cube. Pascal is your Newton by meter square, cancel, right? What you get? 1 Newton into meter, that means it is your 1 joule. Confirmed? Okay. Now coming to the point, energy, this is R, universal gas constant, that means 2 calorie by Kelvin mole. You can repeat it like this: 2 calorie Kelvin inverse mole inverse, that means 0.0821 liter atm by Kelvin mole, that means 0.0821 liter atm Kelvin inverse mole inverse. Here in this case 8.314 joule Kelvin mole, that means 8.314 joule Kelvin inverse mole inverse, 8.314, and you know that 1 joule is equal to 1 kilopascal liter, that means 8.314 kilopascal liter by Kelvin mole, that means 8.314 kilopascal liter Kelvin inverse mole inverse, right? So sum up this unit conversion, that means volume is equal to 1 liter is equal to 10 to the minus 3 meter cube, 1 dmq is equal to 10 to the 3 centimeter cube. Practice it, you will easily remember all this unit conversion. That is pressure is equal to 1 atm is equal to 101,325 Newton per meter square. Remember this one and you can easily remember all this unit, that is 101,325 pascal, so 1.103.325 kilopascal, that is 1.01325 bar, right? 1 liter bar is equal to 100 joule and 1 joule is equal to 1 Newton meter, or you can say like this: 1 joule is equal to 10 to the minus 2 liter bar and 1 joule is equal to 1 kilopascal, right? And your R is equal to 2 calorie Kelvin inverse mole inverse, 8.314 joule Kelvin inverse mole inverse, 8.314 kilopascal liter Kelvin inverse mole inverse, and this is 0.0821 liter atm Kelvin inverse mole inverse. Okay, next coming to the point, now it's time for the numerical. 3000 joule equals to, that means you will convert this joule into liter atm, you will convert joule into liter atm. Now what happens? See this one, this is very simple, because liter atm refers to your R unit, right? You know that R can be converted into liter atm, R can be converted into joule, R can be converted into calorie. Okay, so accordingly what you will do, you multiply with R, you divide with R, because ultimately you will cancel it, then ultimately your result will be 3000 joule. For to get this one, you have to multiply with R and divide with R. So for simplification, just put R unit here liter atm, because you have to cancel joule with joule. That means you will find out the R value in liter atm and you have to find out the R in joule unit. That means you will find out 0.081 liter atm Kelvin inverse mole inverse, and here this is 8.314 joule Kelvin inverse mole inverse. Cancel this one, cancel this one, and this is your liter atm and this is joule cancel here. Finally the answer will be this one, 29.62 liter atm, that is less than 30 liter atm. So what is your answer? Answer is your B, right? Coming to the next slide, the value of 300 liter atm equals to kilojoule. That means you will convert liter atm into joule, right? So here it is your 300 liter atm, multiply with R, divide with R, but the above will be joule and the below will be the liter atm, because you have to cancel liter atm and liter atm, that's why. So put the value of R in joule, that is 8.314 joule Kelvin inverse mole inverse, and here this is 0.0821 liter atm Kelvin inverse mole inverse. Now find out this value, Kelvin inverse mole inverse liter atm. Finally the numerical digit will be like this, and while you are using this calculation you will find out 30.38 30.38 kilojoule, because this is 30,380.02 joule and this is joule, but you have to find out in kilojoule. That means what happens, you divide by 1000, your answer will be greater than 330 kilojoule. That means answer will be your A. Coming to the next slide. The value of 1 joule is equal to, given here, m to the power n liter bar, right? M to the power n liter bar. Coming to the point, that means 1 joule here given is equal to m to the power n liter bar, m to the power n liter bar, and you know that 1 joule is equal to 10 to the minus 2 liter bar. 1 joule is equal to 10 to the power minus 2 liter bar. Here LHS in both cases are same. That means you can equalize this one. Very simple mathematics. M to the power n liter bar is equal to 10 to the minus 2 liter bar. And you have to put n value here, 1 here, minus 1 here. That means what happens, m to the power minus 1 liter bar is equal to 10 to the power minus 2 liter bar. And what you will get, m inverse is equal to 10 to the minus 2. N inverse is equal to 10 to the minus 2. You can write like this, n inverse is equal to 10 to the power minus 2 inverse, right? Because you will operate by the same function or same operation, otherwise it will be wrong. That means m is equal to 10 to the power 2, because minus 1 into minus 1 is equal to 1. Here minus 2 into minus 1 is equal to 2 here. Okay, your minus 2 into minus 1 is equal to 2 here. Or you can write like this, 1 by m is equal to 1 by 10 to the power 2, right? So m is equal to 10 to the power 2. You can do like this. So what is your answer? Your answer is equal to m is equal to 10 to the power 2. That is your 100. Answer is your B. Now coming to the next, in thermodynamics open system, the thermodynamic parameter, you know that open system, energy transforms and matter transform. That means mode of transformation, work and heat, that is minus P dV, and this is T ds, that is PV, and Ts is your PV, Ts is your variable, and you know that matter transfer related to your amount, that is number of moles, in terms of number of moles, that is your N here. What is that parameter, thermodynamic parameter? PV, Ts and N, PV, Ts and N. What is your answer? Answer is your B. So I think this is end of your today's lecture. Thank you very much for watching GIRI classes. Please like, share and subscribe, and stay tuned for tomorrow class. Thank you very much for giving your valuable time. Thank you.